Okay, section 14.4, trig application on page 936, number 42 says this here, the number of degrees, so now we're back to using that symbol theta. The number of degrees theta, which it's the same as x, saying x, north of due east, or south of due east, that the sun rises in Cheyenne, Wyoming, can be modeled by this. So once again, you're given the trig model. You're given the trig model. So we'll write that down. Go ahead and write that down. Theta of t equals. T is the time in days. Would t equal 1 representing January 1st? Use an algebraic method to find what days the sun is 20 degrees north of due east at sunrise. Explain how you can use your graph. So I'm going to show you how to use your graphing calculator to get this actually super quickly as well. So let's write this down. What are we plugging in and what are we solving for? We're plugging in what, where? 20 into the degrees, right? The result, theta of t, gives you the degrees. So we'll replace this with 20 and we solve for t, right? At what day is the degrees 20 degrees? Yes. Okay. So we'll write down this model. I'll write it right here. Okay, theta t equals 31 sine of this. This is just a number. It looks really tricky. 2 pi over 365 looks scary, but it's not. T minus 1.4. Okay, so we replace this with 20 equals 31 sine of this mess, t minus 1.4. And our goal is solve for t. So we undo everything. What do we do next? You tell me. Divide by 31. So you get whatever 20 divided by 31 is. Do you want to just do that and write the decimal? What do you get? So we get 0.645 equals sine of, you know what, I'm going to try this. Let's just do 2 pi over 365. Even though our answers won't be quite as precise, I'm going to convert that to a decimal just so that it doesn't look so awful. So 0.0172. Let's do at least 4 significant digits. That's 0.0172 t, which I don't love t as a variable because it looks like a plus, so I'll put a little tail on it. All we got to do is solve for t. Now, so we can't break any of this up. We can't go any further without undoing the sin. So how do we undo that? Inverse sine. So you have to take the inverse sine of, but the problem is your calculator can only give you one answer, and there are two, and that's why we have to use what we learned about solving trig functions. But fortunately we unraveled all this so that it just looks like that. So inverse sine of 0.645 is, there's a little button above sine. Now here's the thing, is be sure you're in radian mode. That's the one catch. Your calculator has to be in radian mode because in the original problem up here you can tell it's 2 pi that we're using radians for our angles. So that is key. Where is it? Well, it usually looks like a button that says DRG, like this, degree, radian, and that's gradients. Don't worry about that. So I'm going to type in point. First of all, I'm going to make sure I'm in radian mode. I just switched it. I'm going to type in 0.645, do inverse sine, and I get 0.701. 0.701. So I get 0.701 equals 0.0172t minus 1.4. Now the problem is there's another answer. So I'm going to put or, and I have to draw a picture to find that other answer. So radians, where's 0.7 radians in what quadrant? It's less than 1 radian. So yeah, that's just about right here. That's like 0.7 radians, right? That's one answer. Where else is the sign positive? In quadrant 2, right? Remember? So we need two answers. One's there. One's here that we just used by doing geometry. So the other answer is how many radians here? Pi, right? 3.14. So just do 3.14 minus 0.701. Minus 0.701. And that's going to give you your other answer. So it's that, or it is 2.439. Say that again.
Can you simplify the first one? So put together 4 simplified by adding
1.4. Now we can. Now, but we can't do it before then.
Okay.
First you have to take the inverse sign, unfortunately. Yeah. That's a great question. So we have two separate equations. One of them is this, one of them is that, but it's no harder than algebra 1. These are just linear equations. So now we can add, we'll solve each one individually. So first, well, I want to organize this. This will be my first equation, 0.701 equals 0.0172t minus 1.4, and the other one will be 2.439 0.0172t minus 1.4. We're almost there. We just gotta solve for t. So add 1.4 plus 0.701, 2.101. Please correct me if I miss anything, and then divide by 0.0172. So we got about 122 approximately days into the year. That's the first place that'll happen. Whatever day that is, we don't need to figure that out. The 122nd day, and then we got 0.0172t, 2.439 plus 1.4 is 1.4, and then divide by 0.0172. So we also have approximately the 80 sign is positive. Did you get 83 point something? Nope. What did I miss? Let's see here. Did I add that right? No, that can't be right. Made a little mistake here. 2.439 plus 1.4. And then, so that's 3.839, and then divided by 0.0172. Yes, okay. About 223rd day. So, let me show you what this looks like graphically. I could get these answers by not doing any of this if I see it graphically. So I did this ahead of time. So I'll kind of leave that up here and try to show you on the calculator. If I'm going to use the okay, so if I turn it on, go to y equals, let me zoom in here, and go to y equals, you know where that is, and you type in, here's the two equations. Let me try to put this there. I'm going to use the trick Floyd taught me. So this equation is 31, right? That's it. 31 sine 2 pi over 365 x minus 1.4. Is that it? Right? So I want to graph that, and then I want to know where it's equal to 20. So my other graph is see like the lines on the poster. It's a horizontal line at y equals 20, and I just need to know where they intersect, and those are the solutions. So I go to graph, and there they are. There's your sine curve. There's where y equals 20. And those are all the solutions, but I only want the first two. So then on your calculator, to figure out where things intersect, you can go to calculate, second calc, and intersect. I want to find where they intersect. And then you tell it where the curves are. So the first curve is, say, that one, and the second curve is that horizontal line. You hit enter one more time, and look what it does. There's the intersection. See the answer at the bottom? 122. And now I'm going to find the other one. So I go to calculate again, and I do the intersect, and I go, there's my first curve, there's my second curve, and there's my other answer, 223. I didn't do a single computation. I just knew how to use my graphing calculator. Applause.